Lesson 2, Characteristics of Exponential Functions. So this is your go-to chart for exponential functions. Remember that this one is increasing and the other one is decreasing. So you need to remember that there's no x-intercepts, that A is your y-intercept, that the domain goes from quadrant 2 to quadrant 1. The end behavior. The domain is XER. The range is y is greater than 0. It increases when b is greater than 1, and it decreases when b is less or is between 0 and 1, and there's no turning points. So for the next example, we want to determine all the information we know. So for the first thing, x-intercepts, there's none for all of them. Now we're going to find our y-intercept. So for the first one, our a value is 2, so y equals 2. The end behavior is again from quadrant 2 to quadrant 1. And because this is bigger than 1, it increases. The domain is x such that x is an element of the real number set. The range is that y such that y is greater than 0 and y is an element of the real number set. And that's it. For the second one, since there's nothing in front of the e, our y is equal to 1. And e is called Euler's number, and if you type e into your calculator, it's like 2.718 ... It's an irrational number. We use it a lot for exponential and logarithmic functions, so you just have to get used to know what e is. If you needed to find a table of values for e, you can type e right into your calculator to the power of something. So all e is it's a number. It is not a decimal. It is a greater than 1. It has decimals, but it's greater than 1, so it is also an increasing function. The domain is x is an element of the real numbers, and the range is y is greater than 0 for the element of the real numbers. So your domain and range are always the same. For the last one, a is 8. So y is equal to 8. Because our b is 0.75, we know that this is decreasing from quadrant 2 to quadrant 1. It's decreasing. The domain is x such that x is an element of the real numbers. And the range is y such that y is greater than 0 for the element of the real numbers. So for example, whatever this is, 3, 2, we want to match the graphs to the equations. So because every graph will have a certain y-intercept and it's increasing and decreasing, that is how we match. So for the first graph, we know it's decreasing and our y-intercept is 3. For the second graph, we know it's increasing and our y-intercept is 1. For the third graph, it's increasing and our y-intercept is a fraction, so I'm going to guess 0.3, 1 over 3. And the last one, it's decreasing and our y-intercept is 1. Now we're going to look at the bottoms. So for the first one, we know it's increasing because 3 is bigger than 1, and because a, there's nothing there, it is equal to 1. For the next one, we know it is increasing because this is 3, and our y-intercept is a third. For the third one, we know it's decreasing because 1/3 is a decimal, and our y-intercept is equal to 3. And the last one, we know it's decreasing because this is 1/3, and if there's nothing there, it's the same as 1, which is our intercept. Now we just have to match them So the function that has increasing and y equals 1 is this second function, so this is a. This one is increasing in y 1 over 3, so this one is b. Decreasing with y equals 3 is our first graph, and decreasing in y equals 1 is our last graph. So there are our graphs matched. And the last example, we have a table of values. We want to determine an equation for the function. So, and there's also a value missing, so we have to figure that out as well. So to figure this out, we're going to start here. We're going to go biggest number divided by the number in front, and we get 5. This number, 2 divided by 0.4, is also 5. And 0.4 divided by 0.08 is 5. So we know that our base is equal to 5. Our x-intercept is when our y-intercept is when x equals 0. So when x equals 0, our y is 2, so this means our a is 2. So our equation is 2 times 5 to the power of x. Now to find the missing variable, we can do it in a couple ways. The first way is to just use our equation we just made. So we'd go y is equal to 2 times 5 to the power of 2. 2 times 25, it's 50. Or another thing that we can do is that we know that if we take 250 and we divide it by our number that's missing, which is x, we know it has to equal 5 because that's from above. So if you take your big number, divide by the next number, you should get 5. We times both sides by x. So we had 250 is equal to 5x. Divide by 5, and x is equal to 50. So either way works. If you want to make the equation, you can. If you don't want to make the equation, you can also do that as well.